Hello, chemistry students. Welcome to our very last video for Unit 5. How exciting. We're going to talk about electrolysis. And if you'll recall from the last few videos, we've been talking about redox reactions producing electric current, like batteries, galvanic cells is what we call those, right? Now we're going to finally talk about what happens when we do the reverse. When we take an electric current and we make a chemical change happen. That's called electrolysis, and things that do that are called electrolytic cells. So electrolysis is simply forcing a current through a cell to produce a chemical change that would not otherwise occur. Here is an example of that. It's the electrolysis of water. This is what the setup would look like. We're forcing an electrical current through this water, and we are producing hydrogen gas and oxygen gas. Right here you can see where those are being produced. The little bubbles are the gases that are being produced, and they're being stored up there in the upside down test tubes, and this actually happens. You could set this up and make this work. If we examine this a little more in detail, we are looking at the cathode is where the hydrogen gas is produced. The anode is where the oxygen gas is produced. Our electrolyte is a sodium sulfate. It's producing some ions to allow that flow of current. So that happens, our electron flow is going this way. We have our power supply. In the previous example, it was a battery. Now, when is this? This is really fun. It's really neat to do to force this chemical reaction to occur by putting electricity in our cell. What are some practical applications for electrolysis? One, we talked before about our lead storage battery or galvanic cell. What if we reverse that process? When that lead storage battery is discharged, we have this reaction going from left to right. But if we reverse that process and we actually take the products and put them into the reactants and we reverse that process, that is electrolysis. It's a very useful thing that lead storage batteries are capable of because over time, the substances that are used to furnish and accept electrons are consumed and used up, and the battery needs to be recharged. And the lead storage battery conveniently we can do that. And the automobile's alternator, powered by the engine, does this recharging. It takes these products and through electrolysis provides those reactants once again and recharges that battery. There is another application of electrolysis that's actually really an important application, and that is the manufacture of aluminum. So to just give you a little history, aluminum is a very abundant element on Earth, but it's very reactive as a metal. And its iron ore is called bauxite. You may have heard of that before. And the production of aluminum metal from its ore has been very difficult. It's one that is just something that people have not been able to figure out how to do. In 1854, a process was found for producing it using sodium, but it was still very rare and very expensive. In fact, as a little historical tidbit, it said that Napoleon III served his most honored guests with aluminum forks and spoons, while the other guests had to settle for gold and silver utensils. So aluminum has traditionally been very difficult to produce. Now, something really exciting, in 1886, the process of electrolysis was found to be able to manufacture aluminum. And this was really exciting to people. And one interesting little table here shows how the price of aluminum dropped dramatically when it was found that through electrolysis, aluminum could be manufactured. So just to review here, remember an electrolytic cell uses electrical energy to produce a chemical change that would not otherwise occur. It's this situation right here. Our galvanic cells were using the chemical reaction to produce an electric current, such as in batteries. So that pretty much sums up what we've been talking about for these last few sections. If you have the desire to look into advanced ideas, who are the scientists responsible for discovering the electrolytic process for manufacturing aluminum? Research that process more in depth, the scientists who came up with it. Other questions or ideas on any of this for advanced proficiency, look into that, and I look forward to seeing your work.